What's up, guys? We are back after a very long time of no videos. We are gonna finish the semester with some videos. All right. So today we're gonna just talk a bit more on synthetic division. All right. We're gonna talk about how to really treat those remainders and placeholder values, which you will figure out as we get through this video. All right. So I hope you're as excited as I am, because I'm pretty excited. All right, let's get to it. So all of you, across D and F block did outstanding on the quiz. Like, solving this is very easy for all of you. So I'm gonna do it very quick, right? If I solve this example here, I'm gonna say x squared plus 7x plus 10 over x plus 2. I'm going to rewrite that, right? And then from there, right, my algorithm is find c. I'm going to have x plus 2 equals 0. So I'm just getting the denominator equaling it to 0. X is going to be equal to minus 2, right? So I found my c. And then my next step was to draw the L-shaped thingy, right? And then my next step was to get my coefficients. Here in this case it's 1, 7, and 10. And then, add the first term to 0. Add the first term to 0. It's just going to be 1. 1 times negative 2 is negative 2. Then 7 plus negative 2 is going to be 5. 5 times negative 2 is negative 10. That's going to be 0. And our answer here we saw was just our answer. We interpreted this as x plus 5. Right? This was our answer, x plus 5. And write this nicely. But now, I wonder if you guys ever asked yourselves, I know you're very stressed out that you don't necessarily think about this, but why is this x plus 5, right? Well, let me teach you more of the theory of dividing polynomials by binomials. All right, remember we have a polynomial here and we have a binomial here, right? So why x plus 5, right? So I'm just gonna copy and paste my little L-shaped thing here. I'm gonna copy and paste that. Yeah, and I use this. This is what I just used to solve this equation here, this expression here rather. Plus 10 over x plus 2. And then I tell you that this is equal to x plus 5. Well, when you look at what we're doing here with synthetic division, everything atop these coefficients, right? Everything atop these coefficients are what you call placeholder values, essentially. All right? And the placeholder value depends on the largest degree of the polynomial. All right? So here we have a placeholder value of degree 2, right? So apologies, our polynomial in the numerator has a degree 2. I hope you agree with me. So that would mean that our placeholders entail every exponent below degree 2. All right? Right? From degree 2 to x to the power 0. Right? So yeah, so those are the placeholder values. And then now, when we get our answer, right, after we divide, the placeholder values change. And this becomes, they really just collapse to a value minus 1. All right? And then this is our remainder. All right. So what's going on here, right? When we get our coefficients, we are getting the coefficients of the x squared term, which is right there, it's 1. The x to the power 1 term, which is right there, and the x to the power 0 term, which is right here. X to the power 0 is just 1, so 10 times x to the power 0 is just 10, right? And then think about it. We are dividing by an x value here. We're dividing by an x value. It's just x plus some constant. But if I divide an equation like x plus 2, 7x plus 10 by x, my answer here would basically tell me just using this rule that says x over a over x to the power b, xa minus b, right? So this is going to become x to the power 1, right? This will become, this term here will become x to the power 0, which is just 1, right? So that's just 7, but I'll leave it at x to the power 0. And this will become 10 over x, right? Or if you like, x to the minus 1. So that action of dividing an equation, a polynomial rather, by x, right? That action of dividing a polynomial by x is what collapses our placeholder values initially from x to the power 2 to x to the power 1. So when I get my answer now, right, I have to multiply my sums by the new placeholder values after taking the division, right? And don't worry, it's always very systematic, right? It's very systematic. If I have x to the power minus 2 as my first one, my answer will have x to the power minus 1, always. If it's x to the power minus 1, the answer will be x to the power 0. X to the power 0 often is the remainder column, all right? Is the remainder column. So, yeah. So in here, my answer will be, I have to multiply my placeholder times 1, and then add that to my placeholder x to the power 0 times 5. So 1 times x to the power 1 plus 5 times x to the power 0, right? What's x to the power of 0? Just 1. Just 1. So this becomes x to the power 1 plus 5. X to the power 1 is just x, so our answer is x plus 5. All right? And that's how you do that. I know it's a bit weird, but let's do a bit more. Let's do a bit more. And this one has a higher exponent value, a higher degree than the equation we've solved. But really it's the same process. All right? So I get my C, all right? I'm going to write, our new algorithm is going to be get C, right? Still the same thing. So x minus 1, you got your denominator equal that to 0. And then you're going to have x is equal to 1, right? That's C. Then step 2, list all placeholders, right? List all placeholders. So if I have x to the power of 3 here, my placeholders are x to the power of 2 as well, and x to the power of 1, x to the power of 0. You always start from the beginning and go up to 0, and go down towards 0, all right? And then step 3 would be to draw L-shape thing, which I will look for the name of this thing. I don't really know what it is, but anyway. With your code, you gotta draw with your placeholders, all right? And then our C is just 1. Put your C where it normally belongs. And then at this step, you gotta assign the coefficients that have these particular terms, right? So what's the coefficient of x to the power of 3? It's 1. The coefficient of x to the power of 2 is 4. Coefficient of x to the power of 1 is minus 1. coefficient of negative 6, sorry, coefficient of x to the power of 0, that's negative 6. All right? So we go again, the same exact process. Bring this down, so we're going to have a 1. 1 times 1 is just 1. All right? We add 4 plus 1. 4 plus 1 is 5. 5 times 1 is 5. So then you go minus 1 plus 5 is going to be 4. And then 4 times 1 is 4. All right? And then minus 6 plus positive 4 is just going to be minus 2. All right? So we see that we have our placeholders right there. So then we know our answer is going to be 1 minus each of the placeholder, right? So 1, sorry, let me rephrase that. Our answer is just going to be 1, or it's going to be our exponent value, right, minus 1 every time. So this is going to be x to the power 2, right? It's going to be x to the power 1. It's going to be x to the power 0 in our answer. This is going to be our remainder. All right? So, what's my answer then? So my answer is going to be 1 times x squared plus 5 times x to the power 1 plus 4 times x to the power 0. All right? I'll show you how to do the remainder just in the next row. Let's figure this one out here first. So this is going to be x squared plus 5x plus x to the power of 0 is just 1. So it's going to be 4 times 1. It's going to be 4, right? Then our remainder is negative 2. I never told you how to do with the remainder, but it's actually very simple. All you got to do is add it to your equation, right? And then you divide it by the divisor of the equation, by the denominator, all right? So really what I'm doing here is I see that my remainder is minus 2. It's going to be minus 2 over x minus 1. All right? So that's how you do your remainders. All right? Let's go again. Let's do another one. Ooh, this one is interesting. All right? So same process. All right? I get c. My c is going to be x minus 3 equals 0. It's going to be x equals 3. Right? And the next thing I do would be to list place values. You see, in all the equations, you had possible coefficients for all the possible place values. On this one, you don't. But you still need to list all your place values. So really our place values are x3, x2, and by going down all the way back to 0. All right? And then step 3 would be to list coefficients. You might be curious with yourself and ask, what are the coefficients of x2 and x1 in this case? Well, wait and see, all right? So let's see, so list coefficients and draw L thing with placeholders. All right, so our C is 3. So I'm gonna just first write my placeholders, x2, x1, x0, right? It's a bit big. Don't mind me. Yours don't have to be this big or wide in space. It's going to be 3, right? What are my coefficients? Well, I see I have an x cubed term. So the coefficient there is 1. Do I have an x squared term? No. So the coefficient there is 0. Do I have anything with the letter x in my numerator? No, the coefficient is 0. Do I have anything next to the x to the power of 0? I do. So that's going to be minus 27, right? And then I just go again, the same exact thing I've been doing. So this is going to be, I bring the 1 down, so it's going to be 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is just 9. 9 times 3 is positive 27. So in this case, our remainder is 0. All right? And that's really how we're going to do this. So what's my answer here? Remember, for my answers, I need to remove 1 from the exponents of the placeholder values. So I'm going to have here x to the power of 2, x to the power of 1, x to the power of 0. And this is my remainder. All right? So my answer in this case is going to be 1 times x to the power of 2 plus 3 times x to the power of 1 plus 9 times x to the power of 0. All right? So then this is really just going to be x squared plus what's 3 times x to the power of 1 is just 3. So 3x. And then what's 9 times x to the power of 0? X to the power of 0 is just 1 times 9. And this is my answer. There's no remainder. So that's how we go. Let's do it. Let's do the last one, right? I had 7 examples, but I'm already tired. This video is going on too long already. So let's do the last example. 2x to the power of 4, right? Same thing. Get C. So C is going to be x plus 1 equals 0, right? X equals minus 1, right? And then number 2, the next step in this case will be to list placed values, So this time you see we have x to the power of 4. So we've got to start with x to the power of 4 and then go all the way to x to the power of 0, down to x to the power of 0, all the way down to x to the power of 0. All right, then draw L thingy with placeholders and coefficients. All right, draw L thingy with placeholders and coefficients. And then, so where are our placeholders? Our placeholders are x to the 4th, x3, x2, I forgot. Oh no, I didn't forget anything. x1 and x0, right? And remember, this is something I'm not figuring out. It's something you just have to do all the time. What's our value of C? Minus 1, right? So then now I list my coefficients. What's the coefficient in front of x to the power of 4? That's 2. The coefficient in front of x to the power of 3, 0. The coefficient in front of x to the power of 2 is minus 5. The coefficient in front of x to the power of 1, there's no x to the power of 1, so it's 0. The coefficient in front of x to the power of 0 is 3, right? So, yeah, we have our equation set up. So now we get started. All right, x to the power of 4, you bring the 2 down, you go 2. And what's 2 times minus 1? That's going to be minus 2. 0 plus minus 2 is minus 2. Minus 2 times minus 1 is going to be just positive 2. Minus 5 plus 2 will be minus 3. Minus 3 times minus 1 is going to be positive 3. 0 plus 3 is going to be 3. And 3 times minus 1 is going to be minus 3. So 3 minus 3 is going to be 0. So what's my answer then? Remember, it's just for my exponents, I need to subtract 1 from each exponent. So I'm going to have x to the power of 3 here, x to the power of 2 here, x to the power of 1, x to the power of 0. And that's my remainder. All right. And then my remainder is 0. So my answer is just 2x to the power of 3 minus 2x to the power of 2 minus 3x to the power of 1 plus 3x to the power of 0. There's no remainder. So then simply put it in the proper form. X to the power of 3 minus x to the power of 2 minus 3x plus 3. All right. And you don't need to write out the x to the power of 1 and x to the power of 0 every time. I'm just putting that there so you see how the math is changing. All right. This is just how we should be doing our synthetic division from now on. This is how we should do it. And yeah, the biggest thing I want you to remember is how to also handle the remainder, right? So always, if you have a remainder, just add it to the equation and then divide it by whatever the denominator was of the equation that we were dealing with. All right. This is the second to last thing we'll be dealing with on synthetic division. We're almost done, and then we'll move on to inverse functions and composite functions. All right, I hope you like this video, guys, and yeah, let's finish the semester strong. You're all very smart. You all did very well on the last quiz. Let's finish up now. Peace.